Student, in this video I am going to discuss about again few basic concepts about system analysis and design. So basically in this course there is two parts. One is system analysis and another one is system design. Okay, so if we concentrate about system analysis, then we have to think about what the system should do. If we can answer that question, then this analysis part can be solved. So it is a process of collecting and interpreting facts, identifying the problems, decomposition of a system into its component. Okay, so here it shows that it shows that system analysis means, suppose there is a system, then how can we collect the information or we interpret the information, and how can we identify the problem, and how can we decompose the whole system in different sub components so that the information is well organized, the information is well analyzed, the output is well defined, and everything we can know from this analyze for better output. So basically we need to know about what system do. Okay, in system analysis we need to know what system do. In system design we basically try to focus on this: how to accomplish the objective of the system, how to accomplish the objective of the system. It means for a system there might exist some objective. For a system there might exist some objective. It says that it is a process. It is a process of planning a new business system or replacing an existing system by defining its components of or modules to satisfy the specific requirements. So system design involves totally with the planning of the business system. Means how we can develop the whole system, which component will interact which one, what component will give what output, what component will take what input, and how all these things will keep together, and what type of information will pass among all the components. This type of planning or thinking or design can be termed as system design. It means how to accomplish the objective of the system. Objective means there is a specific goal that system will perform, and to achieve that goal we need to follow some design procedure. So comprising system analysis and design, we can focus on these three terms: systems, system, processes, and technology. In all these we are talking about systems. Now what is system? What is system? Okay, here one word is that Greek word, that is system, which means an organized relationship between any set of components to achieve some common cause or objectives. Means we need to organize We need to organize the relationships among different set of components to achieve some common cause or objective. In more formal way, a system is an orderly means in a definite specific way of grouping of independent component. Here again one important term, is independent component. Every component should be independent but linked together according to a plan. Here plan is the design. This is the design. This is the design part to achieve a specific goal. So that is all about system and analysis and design. So here again we can see a system must have at least three basic constraints. First one, a system must have some structure and behavior. It should be connected, interconnectivity and interdependence among the components. It should be structured. There should be a specific behavior of a system. There should be interconnectivity and interdependency between the system components, and the objective of the organization have a higher priority than the objective of its subsystem. Means there might consist of lots of components in a single system, but we do not give higher priority on the subsystems, but we give higher priority to the whole organization or to the whole system, the objective of the whole system. So for example, traffic management system, payroll system, automatic library system, human resource information system, these are some examples. And more from this, there exist some properties of a system. It means the properties like how they are organized, how they are structured, the system is structured well enough or not, because we need to achieve the predetermined objectives, we need to achieve the goal, we need to give the desired output of a system. Interaction means the same point, connectivity among the components of a system. Interdependency means how the components of a system depend on one another, because to function properly there should be good interaction and interdependency. Like in the previous video I have discussed about Google search engine, where we saw different components interacting each other and there are dependencies among them, but there is a specific goal to search the pages. So to achieve that goal, every components need to be interacted, need to have interdependencies, it need to be organized, and there should be integration. Okay, there should be integration, there is central objective. Okay, these are the main properties of a system. These should belongs to a system. This figure we have discussed in the slide in the previous video, where inputs, this is the first element, this is processor is the second element, output is the third element, and there is a control mechanism, and there can be an optional, this feedback is optional one, we can create some feedback loop to the input from the output. Okay, so here again you can see outputs and inputs. The main aim of a system is to produce an output which is useful for the user, and inputs are the information that enters in the system for processing. Before to process, we need input, and if processing the input we get output. and there are processors to process the input to get the output. There is a control section. The control element guides the system, means how things should be processed, how the input should be processed. Like here, one example is that if it is decision making subsystem that controls the pattern of activities governing input, processing and output. So that control system will control everything. It will control how the components will connected, how there should be interdependencies among the system, how they are integrated, and what should be the relationships, how the relationship will be connected with different components. That is the main part. Few more elements like environment, boundaries and interface. Okay, these are the required elements of a system. And more from this, we can say that there might exist different type of system. Okay, here it might be physical or abstract system. Okay, it might be open or closed. Open system means, suppose for example an information system which must adapt to the changing environmental condition, means a system which changes with time or which changes with the environment, then it is open system. And closed system means which does not interact with the environment. So there is a relation between environment with the system. So if it is open to environment, that is open system. If it is closed to environment, then it is closed system. There might be adaptive, non-adaptive. It also means the same thing, means it might adapt to different condition, to different response, to different inputs, to different change in environment. It might be non-adaptive, means it will not adapt to the environment, it will not change anything, it will remain same whatever the environment is. It might be permanent, it might be temporary system. Some system might be natural, some system may be manufactured, some system might be deterministic, some might be probabilistic system. Probabilistic system means there might not be a concrete output, there might be some forecasting like weather forecasting, or like these are like probabilistic system are like decision making system where or predicting system, and deterministic system are like what is specific, like if we want to make some water, we need two molecules of hydrogen and one molecule of oxygen to make the water. This is just an analogy of the deterministic system. There might be social, human machine system. Okay, there are formal information system, there are informal information system, there are computer based system. So these are different type of systems. After that, we can say that there exist system models. So what are the system models? System models, first one is schematic models, second one is flow system models, third one is static system models, fourth one is dynamic system models. So these are different type of models exist, means the model of a system, the model of a system. Okay, here you can see a schematic model, means an architecture. In the previous video of Google search engine, we saw the schematic diagram of the whole system. So to create, before creating the or before designing the whole system or before going to develop the whole system, we need to draw a schematic diagram of the planned or our thinking, how the system will be in real life. That schematic diagram needs to be there, and it shows system elements, it shows their linkages or connections or interconnectivity or dependencies different. So there will be some specific notation, like arrows are used to show information flow, material flow or information feedback. Okay, and second one is flow system model, like in while we do some C programming or C++ programming, we try to draw some flow charts where we try to draw the flow of the data, flow of the input, flow of the information, how the functions interconnected, like what loop is looping and how much time it will loop, what are the condition of the loop, if there is a if else condition, what are the conditions, and what way it will lead through. Those are the flow chart type of conditions, and those, if we can depict through using some flows, depict some models using some flows, those are called flow system models. So what it shows the orderly flow of material, energy, information that holds the system together. So one example is that PERT, program evaluation and review technique. For example, is used to abstract a real world system in model form. Okay. Next one is static system model. And fine example is that Gantt chart. This is very popular one. This example is very much popular because whenever we need to organize our schedule, suppose if you want to schedule your day, means at what time you will do what, at what time you will do what, then Gantt chart is very much essential, or Gantt chart is very much useful. Means it just gives us the picture of the time and activity relationships. Like here it says gives a static picture of an activity time relationship. Means that is the static system model. There might be some dynamic system model. Okay. And then in the last part, that is categories of information. So there are three categories of information related to managerial levels and a decision manager make. First one is strategic information, top one. Second one is managerial information, second one. And third is operational information, third one, in the lower category of the pyramid. So strategic information, in case of strategic information is unstructured, but management level is higher, or we can say upper. And what type of system we can create? Decision supporting system. Like here, few examples are like financial investment, what type of investment should be done, human resources, population growth, trends in revenues. So these are kind of strategic information. So in those region, the type of management level is upper, and what type of system we can create? Decision support system. And what type of volume is what? Volume low consents or low dense, we can say. Type of information is unstructured. Second one is management control information. Here the types of information is moderately structured, but volume of information is medium and moderately processed. Management level is middle, means between these two level. And type of software we can use or type of system we can create, management information system. And third one is operation information. Here what type of system we can create? Data processing system. Here this level is operational information level. This is highly structured, and in here large detailed reports, means the informations are very much detailed one, highly structured. And lower management level and type system we can create, that is data processing system. So that's it. These are the things I want to discuss about in this video. If you find any doubt, please let me know. We'll discuss in the class routine slot tomorrow. Thank you.